So those are the questions that we can see.
Yeah, that's great, Akash. Thank you so much for thank you so much for your session today, for participating at MP University. Again, great to see the investments that you and your team are making in SCOM, in management packs, and some of the things down the road. It looks like the Ignite event next week is a must attend, so I would certainly encourage all the attendees to check out Ignite, check out the agenda, attend, sign up for the sessions, particularly around SCOM and monitoring. I think that'd be very, very valuable. And Akash, I'll make sure that those 3 links are made available to the audience. Sure. So again, once again, Akash, thank you so much for presenting today. We really appreciate your time.
Thank you, Harold. Have a great day, everyone.
Great. Okay. Well, we are tracking right on time, and going to our agenda, we're going to hand it over to Mike Sargent. Mike is senior developer here at Silect. He has been with Silect now for probably 15 plus years, and is a foremost authority on MP development. And Mike is going to present the first of 3 deep dive MP authoring sessions. So Mike, let's hand the reins over to you.
Can you hear me?
Yes, I can hear you just fine.
Excellent. Let's switch over to my headset. And Harold, it's been 17 years.
Well, there you go. I stand corrected.
Good morning, everyone. Let me just share up my screen, which should be that one there. And you should be seeing the MP University main screen.
Yeah, I'm seeing it.
Okay, and here's our schedule.
Yep.
Well, we've got a really great session here today. The last couple of MP universities, we've had really good feedback on presenting a real scenario on how to do something that, while it may not be what you exactly need to do, it's showing how to go through the whole process if you're doing something a little more unconventional. And we've got a really great example of that today. So first of all, I'm just going to do a quick look at the available tools, just discuss some of the pros and cons, that sort of thing. And then we're going to be doing this deep dive into solving a real problem. This came up because one of our other developers had a Hyper-V host shut down due to overheat. There was no warning, and we looked around, and there just seemed to be any way to see that this sort of thing was going to happen so that we could avoid it. So we were discussing it and found out that we can actually monitor it through an add-on which will publish the data through WMI. So we've actually created some new WMI rules and monitors that'll be in MP Studio and MP Author Pro 10.3. Now 10.3 isn't released yet. I'll be demonstrating some pre-release software, but we're trying to get that out very soon. And I think you're going to be impressed with what we can do here. So let's go through this and we'll just we'll get to it. So just in terms of tools, MP Author Free is one that you should always check out. It's a free download. There's no fees to use it. It's targeted at IT professionals. It means it's wizard driven. Now you're going to see effectively this. I'll be demonstrating through MP Studio, but the authoring is very similar to what you'll see in MP Author Free, but not all the features are in the free version. This lets us create intermediate level management packs. That's how we try to describe it. There's a lot you can do there. And there's the link. We'll be sending out these slides, so don't worry about copying that down. Now, of course, to pay my princely salary, we have MP Author Pro. Now, this is a licensed product. It's just the same binaries as MP Author Free, but we install a license file, and as soon as we see the license file, we enable some additional authoring scenarios. Link there. I could go through all of those, but I think the easiest way is to go to the website. There's a comparison chart there. You'll get a sense of what's there. The big one, of course, is MP Studio. Now, this again is a licensed product, but it manages the full MP lifecycle. Now, it has full authoring. It's the same as MP Author Pro, so that's what I'll be demonstrating. When we say full MP lifecycle, It stores MPs in a SQL database. It provides full version control, a lot of documentation, audit history, reporting, multiple users. The list goes on, and I don't think you need to sit here and listen to me yammer about it, but the website will be glad to give you more details there. The other thing is it connects to one or more management servers to make it easy to deploy these management packs to management servers. You can compare. There's reports on management servers and changes and what's available. So I strongly recommend you take a look at that. We've put an awful lot of effort into that over the last 17 years because, we started working on that about 3 months after I started with Silex, so it's almost 17 years now. And that's what I'll be demonstrating here. The other popular thing that people use is VSAE, the Visual Studio Authoring Extension. Now, this is honestly more targeted at programmers. It's a free extension to Visual Studio. It's a lot of XML editing, but they do provide IntelliSense so that where possible, they can provide some better hints as to what's in there. It creates these things called .mpx files. And this is an area where fragments can really help. We'll be talking about fragments in the next one. You can download VSAE from that link there. And as I said, we'll be sending out these slides, so don't worry about that. Fragments are really neat. And Kevin Holman's got a talk later today that you really do want to check out. Basically, a fragment is a template. It's a chunk of the XML that will be in a management pack. And there's a small number of replaceable parameters. And you simply replace those with actual values, and the code is complete. Now, Kevin shares a large library of fragments. There's another Microsoft fellow named Kevin Justin who's provided some. Silex has provided a couple. So these are all available. In MP Studio, you can actually download them. We keep a master copy of all of them that we have access to on GitHub. You can download those free. Using VSAE and fragments, use search and replace. So basically, you create a file, you copy in the fragment body, you search and replace for the template parameters, and you're done. In MP Studio or MP Author Pro, you can do the same sort of thing. You can import a fragment. We bring up a dialog that lets you use browsers. So if you want a class or a registry, that sort of stuff, we have browsers for that. Makes it a little easier, I think. So Kevin's fragment library is, again, freely downloadable. There's the link. So those are the sorts of tools we've got. There are some others out there. I don't have much experience with them. In particular, one I probably should have mentioned, because Harold's going to be mad at me because I didn't, is the Silex portal, which is web browser based, allows authoring using fragments behind the scenes. I really should have included that. I'm going to get hell for that. Sorry about that, Harold. So let's talk about our authoring techniques. And for this, we're going to look at that scenario. Give me a second. I'm just going to take a sip here. So as I mentioned, one of our developers came to me one morning and he said, hey, last night my Hyper-V host shut down because it overheated in the middle of the night. And there's no warning. He's got SCOM running on it, but unfortunately nothing hinted that it was about to overheat. I think he needed to blow out the fans or something like that in reality. And it was probably also doing some updates overnight or something like that. Got very, very busy. So what we're going to do is we're going to go through this whole scenario, and we're going to put together something, a management pack that'll monitor CPU overheating. It'll collect the data. It'll produce some views so you can see them over history. It will also consider fan failure, because that's another wonderful case. The Hyper-V host I'll be demonstrating this on doesn't actually support the fans, can't report them, but also how to do that sort of thing. As I mentioned, there's really nothing out of the box to monitor this. So we'll be showing you how to integrate with a third-party tool, which is the Open Hardware Monitor. And we'll show off these new WMI rules and monitors that are being added to MP Author and Studio and Pro Author Pro 10.3, which, as I mentioned, we hope to get out very soon. The tools we're going to use is Open Hardware Monitor. There's a couple of links there. I'll bring up the web pages in a second here. And the one thing you really want to do is you want to use the options from the menu. Options run on Windows Startup, so it runs all the time. Now, that's roughly what it looks like. It shows things like CPU and GPU, memory, motherboard, disks, etc., whatever it can get access to. It'll report on the temperatures, power, fan speeds, voltages, load data, etc. It's licensed under the Mozilla Public License 2.0. I know in corporations, public license stuff is sometimes allowed, sometimes isn't allowed. You're going to have to make that decision yourself. What we'll do is I'm just going to see if I can bring that up for a second. And so I need to go away from full screen here. And I want to bring up this, and we'll just share this over here. So this is the live data on my host. This is my VM host that I'm using. So as you can see, it'll report the clock speeds, the bus speed, the clock speeds on the 6 cores in this Xeon processor. It'll report on the temperatures. So there's 6 core temperatures, and there's a package temperature for the whole CPU here. You can look at the loads. Obviously not much is happening on this system right now, which is pretty much what I would expect. The total power used by the package, the cores, etc. And then there's additional data here for memory, which is basically just how much memory is being used in this case. There's some information about hard disks here, including temperature for some of them. And I'll just bring up the same thing, but running on my local system. There's a bit more information here because on this system, it can actually retrieve information from the motherboard. And so it has CPU voltages, temperatures from motherboard sensors, and fan speeds here. And you'll note that of the 6 fans, 2 of them are running at 0 RPM. It's not clear to me whether those are just not running because it's not generating enough heat right now. The fact that the max column shows that they have run one of them at 43,500 RPM. That doesn't seem likely. That would have been running so fast, the whole computer would have flown out the window. But again, we have the ability to collect fan speeds here. Controls, there's fan control there. So fan 4 and 5 are supposed to be running at 68%. Actually, I may need to check my fans, because it says they're supposed to be running at 60-odd% here, yet they're running at 0 RPM. So I may need to open up and look at my fans in this system. In this, I have a Core 990, so we can look at the clocks. I don't think that's terribly interesting, but we can look at the temperatures here, the loads, the power, and I'll just look at just some of the other things you can look at here. Memory we sort of looked at. Here's my GPU. So again, we can look at some temperatures there if that's important to you. Disk temperatures and load. There was one other thing I wanted to point out to you, that this Intel SSD actually is reporting the remaining life. And that might be something you're concerned about. If your SSDs actually report life, you might actually want to raise alerts when they get below, say, 20 or 10% or something like that. That disk, I'm not even sure which one that is. Oh, I know which one that is. That disk is probably 7 or 8 years old. The fact that it's still reporting 100% seems surprising, but that's what it's reporting. The reason I am running Open Hardware Monitor on this local machine is this is where I'm going to be running MP Studio, and this is where I'm going to query with WMI to get this information. So I'm having it here so I can just use it locally. I don't have to. And there's this option, run on Windows Startup. On this machine, I don't have it set that way, but on the actual Hyper-V server, I do have it set that way. So it's running on Windows Startup. So if we come back to here, I'm going to, and of course we go all the way to the start. I know there's a way to continue from where we are, but there we go. So now we're going to get into a demonstration. I just want to go through what I'm going to show off. So we're going to create a class and discover Open Hardware Monitor. So we only want this management pack to be running on machines where Open Hardware Monitor is running, because we're going to query Open Hardware Monitor. So that's the first goal. The second thing is, where we have Open Monitor, we're going to create and discover a class for CPUs. And for each CPU, we're going to create a class for temperature sensors. And I did skip one thing I was going to talk about. I was just going to show the documentation for Open Hardware Monitor. So openhardwaremonitor.org. That link is in the slide deck, so you'll see that. Download it, details on it. There's documentation on it, what's supported, and this data interface. Here's the detail there. And this is the details on what's published to WMI. So there's a number of hardware types that are published. See if I can actually get away with it. Main board, Super IO CPU, NVIDIA GPU, GPU for NVIDIA and ATI, T-Balancer, I'm not even quite sure what that is. Heatmaster is probably heatsink, and hard disk. Sensors are for voltage, clock speeds, temperatures, loads, fans, flow. I guess that's for a heatsink. Roll and level, I'm sure they give better descriptions here. And it shows how it goes together. So there's a number of hardwares which will have individual sensors below them. They're all under this root Open Hardware Monitor namespace in WMI. I'm not going to go through all the docs, of course, but it is fairly well documented. Come back here for a second, and I've done it again. Sorry about that. You'd think I'd learned. So as I said, for each CPU, we're going to discover the temperature sensors. I'm going to manually create a relationship so that temperature sensors are hosted by CPU. I'll talk a bit more about this. This is something we do want to improve in MP Studio. So we'll deal with that. I'm going to create a folder where we're going to put the views under. This is generally a good idea, that your management packs or related management packs should have a folder so that all their views are under them. It just makes life easier. We're going to create a rule to collect that temperature information so we can view it as a performance view. We'll create the performance view, of course. And then we'll create a monitor to raise alerts when the CPU temperature is too high. And I'm going to actually go through and demonstrate all of these things. Needless to say, I actually already have a management pack working and running. So that's ready and it's collecting data. So the MP I create during the demonstration is not going to be deployed, but a virtually identical one has already been deployed. So let's go through. Here's MP Studio, and I just need to bring up my Word doc here so that I know what to walk through, and I can copy and paste so I don't make typing mistakes. So for those of you who haven't seen MP Studio, we have a list of management packs here. I filtered this list down to just MPU 2021, but we actually have multiple folders here, etc. We have management groups, but we're just going to concentrate on this one folder for the time being. So here's our MPU 2021 folder. As I mentioned, this is pre-release. This is what will become 10.3, but it's not complete yet. So on the very unlikely chance that something actually throws an exception or racks up here, remember it's development software and we'll get those all fixed before release. Honestly, I don't expect a problem because I've gone through all this a couple of times, but you never can tell. When we create, well, sort of all of our wizards have a fairly similar format. There's an introduction which tells you what it's going to do. There's several steps that collect data. There's a create step which summarizes what it's going to do, and then you create, click finish. So when we want to create a management pack, we need to give it a name. The name I've chosen is Silac.hardware monitoring. We automatically will try to generate a good display name for it by taking out the dots here. So that's what you see here. We're starting at version 1.00. You can change that, of course. I can't see any need to for myself at this point. And we have a description here. So this is where we would actually put in a longer description of what this is. It's free text. You can put in whatever you want. We've put in just something to get started with, but of course you're free to change that. During this demo, I won't be changing descriptions, but you probably should to try and produce better information. You know, the old saying, it's you write something once, but you read it about 10 times. So a good description is certainly going to help. We're going to save it to the store in this folder that we were looking at. So I don't need to change anything there. Here's where we get to choose which versions of SCOM we're going to talk to. We want to create a management pack for Windows, and I'm going to be targeting SCOM 2019, but we also still support.
Mike,
yes.
Mike, just want to jump in. You're still sharing the Word doc. Just wanted to make you aware of
that. Thank you, Harold. Okay. I'll just cancel that and I'll come back to, I'm glad you told me that. Now I'll share MP Studio. Okay, sorry about that, folks. And thank you, Harold. So as I mentioned, this is MP Studio and the folders here. I'm not going to go through it all again, but we'll go through the create new management pack here. This is that introduction screen I was mentioning. So here's where we collect the data. I'm going to just paste in the name I want. Here's the display name, which was just the regular name without the dots, version number, and the description. I was just telling everyone they should update that. I'm not going to. We're going to store it into the folder that we started from, so that's a good default here. And here's where we get to select. We're still supporting SCOM 2012, but as Akash mentioned, that's going out of support early in 2022. So, you know, if you're still using SCOM 2012, you really need to upgrade soon. When 2022 comes out, we'll be adding support for that as well. But for this management pack, I'm just going to target a Windows management pack for SCOM 2019. I'm going to create an empty management pack because I want to fill this all in. And so here's our summary of what we're going to create. And when I click finish, it creates the management pack. So here's our empty management pack. We have folders here for classes and discoveries. We don't have any of them yet. In fact, the only thing that's in here is a language pack that has one display string for the management pack itself. So this is as empty as you can be. But we can start creating things. So we want to create a class to discover open hardware monitoring running on machines. The trick with that is that open hardware monitoring doesn't actually install anything. It's what they call a portable install, so nothing in the registry that we can look at, but we can find it through WMI. So we're going to query. This is where I could change and query to another machine, but as I said, I've got open hardware monitoring running on this local machine. It just becomes a little faster, so we're going to stick with that. Our target is Windows operating system because we're looking for, in this case, Hyper-V host, so that'll always be running Windows operating system. The more narrow you can target something, the better off you're going to be. So now we have our WMI query. So let's browse for this. And we're going to expand SimV2. And when it expands, and unfortunately it takes a few seconds to load all this information up, it will get there shortly. What we're going to look for is we're going to look for the process running. So we're going to be looking at the Win32 process class, which is way down here. I thought process. So this has all the processes. Let me just do this and we'll sort that. And we're just going to go down for open hardware monitor. So here's the process of open hardware monitor that's actually running right now. And that did not exactly do what I wanted it to do. Sorry about that. Okay, so we want to actually return some data on that. So we want the caption. We're going to return the caption when the caption is Open Hardware Monitor. So basically, this is just going to do an existence largely. So where it finds a processor called OpenHardwareMonitor.exe, it's just going to return the caption for that because that's all. We don't care what it returns as long as it returns something. We have a property of the caption because that's the data we returned. We're not going to change that at all. We have the identification, so I'm just going to make some quick changes here. I want to give this a slightly better name for the class. This is the class name. And the default, we take off the name of the management pack. So select Open Hardware Monitoring. So we're left with Open Hardware Monitoring class, and we remove the dots to give a sample display name, which is pretty good. So we're going to leave that. Our base class in this case is local application. Obviously, it's an application that's running. That seems like a very good choice. And we're going to identify the discovery. And I think actually that may have chosen the same thing. Yeah, that's actually what I've got here. So Open Hardware Monitoring Class Discovery. This is based on the class. We simply tack the word discovery on the end of it, which seems pretty good in this case. Standard for discoveries, for schedule for discovery is basically once a day. We're going to leave that. And here's our summary of what we're going to do. We can go back and change anything we want. There's no need to do that in this case. So now we've created that discovery. This will go out to all Windows Server machines, anything running Windows Server OS. It'll run this WMI query, and if it finds Open Hardware Monitoring running, it'll actually create an instance of that class. So the next thing we want to do is we want to find the CPUs. So if I bring, let me just bring this back up. This is not necessarily the best view of it, but what we're looking for, actually that's what we want here. So we want to find the Intel Core CPU, and we're going to look at the temperatures here. So let's create that next class to discover the CPUs. Again, we're going to use WMI here. We're going to look at the local machine again, but in this time, we only want to look at machines where Open Hardware Monitoring has been found, because that's the only machines that's going to have the namespace that we're interested in, which is Open Hardware Monitor. And so we want to look at hardware here, and we're going to look at CPU in this case. So we want the hardware type to be CPU, and we want the following information. We want the hardware type, we want the identifier, we want the name, and we want the parent. Oops, got those right. Instance ID and process ID will change. There's no good sense in using those. They're not as constant as what we want, but this will be sufficient for us. We're going to let those properties be created just as they are. We don't need to change that. We're going to change the target name. This is the class name that'll be created. That'll become CPU class. And our base class in this case is actually going to be local application. There might be a better class that we could use. And I'm going to be showing, we're going to use a different class for the next one, and I'll show how that's wired up. But this is not a bad choice. There are probably better ones, but this is not a bad choice. We're going to identify the discovery here, and let me just cut and paste this name. Even bad. And again, our schedule is once a day, our summary, we create it. So now, when this management pack is deployed, any machine that's running an Open Hardware Monitor is going to collect all of the CPUs. So we're going to have class instances for all the CPUs that are discovered by Open Hardware Monitoring. We'll be demonstrating that in a minute. So the final thing we want to do is we want to discover the temperatures. So again, we're going to create another WMI discovery. in this case, we want to go and we want to discover those for the CPUs. So only where we have a CPU, and for each CPU, we would want to discover the temperature. So the particular machines I'm looking at only have a single CPU, but if you had a multiple CPU, not multiple core, multiple CPU, this would actually create more than one class. So that's why we want to target this, so we have temperatures per class. Again, we'll go out and do our browse to open hardware monitor, but this time we're going to go to sensor. And I'm going to search down for temperatures. So under the sensor type here, we're going to go down to temperatures. And I'll look at this one in particular. So this is CPU 0, temperature 0. And that's the one I want to start with. And we'll show you how this works. So I want to get the identifier, the index, and this will become crucial later on. We want the min-max values, the name and the parent properties here. And we want the parent and the sensor type. Where's sensor type? There it is here. So this will find all of those temperatures for that parent, and you're going to see how we can change some of the stuff and make it a little more general later. Because I only have one CPU, in this demonstration, I'm going to limit it to one, but we don't actually have to, and you'll see how we would do that a bit later. We'll just use the defaults for the properties. We're going to identify the target, so we're going to give this a slightly better name that will come up as just CPU temperature when we're done. The base class in this case, I'm going to leave it at local application, but I'm going to change that. Right now, because of hosting, what I want to do is I want to host the temperatures on the computers, or on the CPUs, sorry. But we don't have a hosting relationship here, so we can't actually show that. And that's something I really would like to get in for the next release. So we'll change that, but it's local application for the time being. We'll give our identification for the discovery. Temperature discovery, our schedule again once a day, and we're going to create that. Now, as I mentioned, I wanted to actually have the temperatures. I'm just going to save this. You see a list here when we save things. This is all the changes that have made, all the additions. This is all additions, of course. We can put comments into any field here to say why things were changed. We can put an overall comment in why this version was created. I'm not going to do any of that for this demonstration, of course, but this is part of that life cycle that we were talking about for management packs. Now, as I mentioned, I want the temperatures to be hosted by the CPUs. So we're going to do the following. We're going to edit the XML for the whole management pack. I'm going to come down to the end of entity types, which is here. And I'm going to paste in some canned code I already wrote up. And hit enter there. And in a second, this should recolor and format. Yeah, it didn't indent properly. But what we're creating is a relationship. CPU host temperature. It's a hosting relationship so that the source class is this CPU class and the target is that temperature class we're looking at. Now, we have to make one more change here because the temperature class is local application right now, which is not hosted by that. So we need to change this to system.application component, which is what I would really have liked in the first place. And do that from directly within MP Studio right now. And so that's done, and I'm just going to go in here and I'm going to give the relationship a display name. By pasting in the XML, I didn't get a display name in there, and that's done. So there's our complete class structure. I'm just going to save that. There's the addition and some changes here. Just a quick thing you can do in all versions of MP Author and MP Studio. We have some things here to check for missing display names. We just filled that one in, so we don't have it. We can verify the management pack so that there is no verification error. There's also the ability to run the best practices analyzer from within MP Studio and MP Author. Takes a second here. If you've never seen the best practices analyzer before, this goes through and looks at some sort of the deeper semantics of things. I'm just going to tell it not to show me the things that pass because they're not very interesting. So all I'm doing is looking for some color down here. So management pack elements should have knowledge articles. I didn't create knowledge articles for the management pack, for the class discovery, the temperature discovery, or the open hardware monitoring discovery. In practice, we probably want to create those. It's not complaining about anything else, so that's pretty good. Now, with that done, we can actually go back to our management server. And let me just go to my management server here. And what we have is the discovered inventory. So here's our open hardware monitoring class. We have one instance of this. As you can see, there's the display name is not ideal here, but that's from the older MP. I probably didn't update it. The full path says this was found on demohost.silecdemo.com, which is the host machine. And the description is openhardwaremonitor.exe. So that's the one place in my infrastructure where we have the open hardware monitoring on a managed or monitored system. Let's look for the CPU class now. So we'll change the target type here to CPU class and select it before hitting OK. So we found one CPU on that machine. So on demo host again, we've found a hardware type of CPU. The identifier is CPU 0. The name is an Intel Xeon, etc. All that information is there. We only expected to find one because we know that's a single CPU computer. Let's look at the temperature because here's where we actually get interesting. So all targets, select the temperatures. And in this case, you'll see that we actually have, let me see if I can sort those, 6 temperatures that have been discovered. So each of those has a name. There's the path, which is going to be pretty predictable. It's just the computer they're on. Display name, I think, is probably the same as the name here. Identifier is probably, again, the same. But you remember I made a point that we need the index here. And you're going to see how that plays out. I'm actually going to be using the identifier for the parent, but that's neither here nor there. And there's our name. So the CPU core temperatures 1 through 6 and the package temperature here and some information there. So we have discovered all of those things. Now let's go back to MP Studio. We want to create a folder because we're going to want to put all of our views underneath that. This is the parent folder. And while this name looks horrible, it actually is just, if we look at just the display name, it's the monitoring thing. So we'll give this a name. And we're going to actually change the display name in this case as well because root folder is a really bad name. So we'll just call this Select Hardware Monitoring. And this is one of those cases where using a good display name is really good for you. Our summary, and we'll create it. So there is our folder. Now, let's create a rule to collect that information. Here's where it gets interesting. This is the new code. Again, we're going to be querying on the local machine, and I've got open hardware monitoring here. What we want is to query on the temperature. So there's our temperature here. Our WMI query. So we want open hardware monitor. We want sensor. What we want is we want to get the value of that sensor in this case. And we want an identifier. So I'm just going to choose one of these. Where are we here? Clock. I missed temperature. Yeah, there we are. choose that guy, and I'm going to select identifier equals. Now, if this rule ran, it would only run against this one particular temperature, but we're going to change that. So this identifier here says this particular identifier, but because we're targeting the temperatures and we have the 7 of those, we can actually use the identifier from the target. So by substituting that in here, SOM will replace the correct identifier from each of the temperature instances when it runs this rule, and we'll be collecting against the 7 temperature sensors. We're going to do that again later. You'll get to see what happens there. And now we just want to fill in some good values for the performance parameters that we're going to create. So we'll call this open hardware. Select hardware, because that's where we started. We'll call this CPU temperature. For the instance here, I'm actually going to use the target identifier, the same thing that we matched against earlier. I think I need to select all of it and do that again. It shouldn't have been that long. So this will be replaced with that identifier, which is that slash Intel CPU /0 / temperature /0, 1, 2, 3, 4, 5, 6, 7. And then for the value, we have this from the data. We only have the one thing. So we'll just be using the value here. We'll quickly go through and give this a better identifier. So temperature collection, that seems good. So we want to create a view. I think actually the name is fine. The folder we want to use is our Silex folder that we just created, our monitoring root folder. And we'll also save the information to the data warehouse. We're going to run, I'm going to sort of see here, I'm going to use every 5 minutes so we collect lots of data quickly. You probably wouldn't want to do that in reality. And then we can go back and review everything. Going to widen this quite a bit for everything to fit. We can go back, of course, and change things, but we don't need to. So there's our rule that's been created. Now, if we go back to SOM, as I mentioned, I've already deployed a much earlier version of this. So we actually have a Silex hardware monitoring folder, and underneath that, we have this CPU temperature collection performance view. This is the results of that rule. So as you can see, we have, let me just expand instance here a bit. So there's the 7 sensors that we were talking about. This is collecting the data every 5 minutes. We can select the time range to significantly longer values if we want. I wouldn't be surprised if I could go back a couple of months here, but let's just go back to hours for simplicity here. There's a lot of personalization we can do to this view if we need to, but this shows us that we are collecting that data from the rule. So the rule collects it, the view provides, shows it to us. Now, let's monitor this. Now, one of the things I'm going to do is I'm just going to go back to my demo host for a second. And I've got a separate program running here, which is a real cheat. I use it for testing. And one of the things I can do is make it eat CPU. So you'll note the CPU here is pretty low. I'm just going to tell it to max the CPUs out. And if you look, all of a sudden it goes to 100%. The reason I'm doing this is simply to drive the CPU temperatures up so that we start to get alerts generated. I just want to demonstrate that. And you'll notice that the temperatures have already gone up. They're well into the 70s now. So let's create our monitor. By the way, because we're only sampling once every 5 minutes, I needed to do that early. So we'll create our WMI monitor again. We'll browse locally, but we're actually going to deploy remotely. We're going to be targeting our CPU temperature class here. It is performance state, so that's a good choice. Our WMI query is actually the same query that we used for the performance collection rule. but I'll just go through this again because I want to show this to you. So we'll be collecting the value where the identifier equals, and it doesn't actually matter that I selected load 1. Oh, that's load. Sorry, I want temperature here. Yeah, so temperature. So the value for that particular thing. So there's our viable WMI query. And what we're going to do is we're going to replace the identifier with the identifier from the target. One thing I'll very quickly show is because we now have a query which is no longer valid WMI, if we bring the browser back up, it complains about it. And if we change it, we're going to lose this. You'd have to put it back. I haven't found a way, or I haven't thought of a way around that yet. So it's something we're worried about, but it's something you need to remember that if you do update it using the browser, you'll have to go back and put the target information back in here. Fortunately, it's a real quick click thing. Our performance mapper. This is going to look awful similar again. So I'm going to use static hardware, CPU temperature. We're going to use target identifier, and we're going to use data value, of course. We're going to give this a better identifier. If I can cut and paste. CPU temperature monitor. We can run this using the default run as credentials, so we don't need to change that. Here's where we get interesting. So we want to create a monitor, which is a 2-state monitor, healthy and critical. We're just going to use a simple test here because that's the easiest way to throw alerts here. You'd probably want to do a consecutive or average, something like that. But what I want is, I want it to be healthy if the temperature is less than 70 degrees C, and it's going to be critical if it's more than that, which is updated here. So healthy if the value is less than or equal to 70 C, and critical if it's greater than 70. We want to generate an alert for this. It'll be critical because that's the state we've produced. We want to automatically resolve the alert. We could change the display name. I'm just going to leave it for the time being. Priority and severity are okay. I am going to make a slight change to the description here. Something that seems more interesting is to put in default values for things, because it eliminates some issues in SOM where you have no value. So I think we'll be making our default descriptions modified to actually provide, say, empty defaults or 0 defaults for things. It just makes life a little easier for you. And then we can create that. So that is the end of the creation of the management pack. We'll just save this new version. Now, we can come back to SCOM here. You'll note that the temperatures have gone up. Let's see if I can get it to tell me a temperature. So we're at 73 here. We hopefully will have some active alerts by now. Let me just do a refresh on this. There we go. So here, for instance, is an alert that was raised 2 minutes ago. Tells me that the instance, gives me all the information here. It's on demo host. Tells me what it is exactly, current value. We have additional knowledge. We should probably create knowledge for the monitor, that sort of thing, but that tells us everything we need. And if I go back to my host and turn the CPU back down to something reasonable, these temperatures will go down fairly quickly. The cooling is actually quite good on that system. You'll see that they've all instantaneously returned lower. It will take about 5 minutes for these results to be reflected in SCOM because we're only sampling once every 5 minutes. We can come back and just take a quick look at that a little later just to see that the alerts have closed. They'll probably close in about 2 minutes here. If I go back to my PowerPoint, I think the only other thing here was a Q&A. So we have about 10 minutes left. We will come back and just take, I'll actually leave this up because this will refresh shortly. So we can do Q&A now. Oh, I was going to actually point out what we can do with fans, and I think that's probably fairly obvious. Oh, that was not what I wanted to do. If we wanted to monitor fans, and this is what I meant about, this is a development version, we'll ignore that. Because we had a CPU class here, and let me just bring this guy back so you can see where the fans are. Fan speeds, in fact, in this case, are on the motherboard. And that those two fans are still at 0. So we would want to create a motherboard class, which, oh, it's going to keep doing that, isn't it? I'll have to figure that one out, sorry. Let's just see what happens if I reload that. This will probably work better. We'd create another WMI class, same sort of thing. We actually want the open hardware monitoring. Our WMI query will be for open hardware monitor for the hardware. We have main board, which I presume is where we're going to find this. We would create a class for this. I've got my notes. I didn't do the notes for this because we can't actually do it on the real machine. So the basic idea would be to create classes for the main boards. There's typically only going to be one. And then we could do the same sort of thing for fans. So if we look at sensors here, and we'll just do a quick heat on this, we can find fans here. Should be fans here somewhere. There we go. So here's fans. Interesting that, oh yeah. So we could select fans. There's the identification for those fans. You will probably need different classes for different types of motherboards. In a large organization, of course, you're going to have a lot of machines that are very similar. But you know, Intel 0 CPU is going to be fairly common, or AMD 0 CPU. But you will need additional classes for additional types. So we'd create the fan. We could select the value here, identifier. We'd replace this when we do it, and then we can create a monitor looking at the fan values for less than a certain threshold. We may have to disable it for some if the fans are legitimately not working. I'm getting 0 for 2 of my fans here. I don't know if those aren't installed, although the max values say at some point they were, or whether they've actually just stopped and I am heading towards a problem. I'll check that out later. But effectively, it's almost identical to the way we did it with the CPU. You're just going to need a slightly, you know, different classes and different thresholds. Okay, so we probably have our, yes, our results. Our alerts have closed. If we come back here, we'll see our temperatures are back down. And if we look in my closed alerts view here, there's the alerts and they were closed. I don't know if there's any additional information that's logged about the final temperatures. Yeah. So this temperature went down to 60, and that's when it closed. It was 71 when it raised the alert. Okay. So that's probably everything I need to show here. As I mentioned, we do have a couple of minutes left. Let me see if we can bring up the Q&A here. And we'll see what we actually have. The chat, thanks, Bob, and the Q&A. Am I not seeing anything from? Oh no, there it is.
There's a question, Mike, from Stephen regarding the WMI tool.
Okay.
And if you look under published, and you probably go to the end of that list or close to the end of that list, you'll see the question.
Using the WMI tool, how can you deal with queries that are over the 1,000 limit, such as directories and building a discovery for a log file? Honestly, Stephen, I don't know what 1,000 limit you're looking at. I don't believe our WMI tool has that. I think it'll fetch everything. If it doesn't, you can, I mean, it's WMI, so where you're setting a where clause, you can modify the query yourself. You can edit those queries. As you saw, I replaced some fixed text that we got when we did the query with the target values, so you can edit it yourself if you have to. Of course, this is from 2022. That's the only question I'm really seeing here. We still have 5 minutes, so if there's anything else I can help you with, please feel free.
Yeah, for sure. Thanks very much, Mike. And yeah, let's keep an eye on those questions. If you do have any questions for Mike related to either his session or other more general questions on MP development, feel free to use the Q&A window and ask Mike, and we'll keep looking at that. As we wait for those questions to come in, we do have a short break before Bob from Top Core joins us for our second deep dive MP development session at 15 minutes after the hour. So that's in about, well, just a little under 20 minutes from now. Bob will be queued up for his session. And again, in the interim, please feel free to ask any questions you may have. And with that, Mike, I'll ask you to stay on, check the questions, and thank you very much for your session.
Oh, you're most welcome. I'll be glad to stay on.